This is the Electronic Session Institute Laboratory. In this work, we implement a double field induction generator system for extracting maximum power from the wind. In this work, we divide the work into two parts. The first part is permanent magnet synchronous motor used to emulate the wind turbine, and double field induction generator used to extract the power from the from the permanent magnet synchronous motor and connect it to the grid. So in the first part is the wind emulator. We control the permanent magnet synchronous motor using field-oriented control to produce the reference torque, which is extracted or developed by wind turbine emulator model. The wind turbine emulator model is we give the wind speed to the wind turbine emulator model and the rotor speed and the pitch angle, and it proposes the torque which will followed by the permanent magnet synchronous motor to emulate the wind turbine characteristics. The second part is the double field induction generator part, which is used for extracting the power from the permanent magnet synchronous motor and transfer it to the grid through two sides. The first side is through the stator, which is connected directly to the grid, and the rotor side, which is connected to the grid through a back-to-back converter. The back-to-back converter has two parts. The first part is the grid side converter, which is responsible for maintaining the DC link voltage constant, and the rotor side converter, which is responsible for extracting the maximum power from the wind emulator using one of maximum power point tracking technique, and also to provide reactive power to the grid through the rotor. In this system, we use two D-space system to control this work. The first one is 1104, used to control the permanent magnet synchronous motor using field-oriented control. The second one is 1202, micro lab box, used to control the double field induction generator and the two converters. Here is a board used for controlling the rotor side converter using a current sensor and voltage sensor and some contactors for safe connection and disconnection. And this board used to control the grid side converter using also voltage sensor and current sensors and some sort of contactors to safe connection and disconnection, and we use also resistance to smoothly charge the capacitor at the beginning of the experiment. This is a board used for controlling the permanent magnet synchronous motor using the field-oriented control. The permanent magnet synchronous motor is controlled using this inverter, which we control this inverter to control the permanent magnet synchronous motor using field-oriented control. And thank you.